So guys, I'll be presenting on the SS7. SS7 has been a hot topic for last 2-3 years, and we've been doing the assessment in the SS7 since say 4 years, and we found some good issues. And today I'll be presenting what exactly we found in the SS7, how it was found, and what was the challenges we faced. Okay. Basically about me, I work as a telecom security consultant for various firms, either freelance or on a project basis. I love telecom. Love to break the telecom, presented in Nalcon 2012, 15, as well as in Cocoon. So let's start with SS7. Basically, key problems with the SS7s are everything on the network everything on the network is a trusted one. Everything who are on the SS7 network are the trusted piece. Okay, operators will only have the access to the SS7 network. So let's take an example. If some new operator comes in, so they think that okay, this access is limited to you only. You cannot share this access to someone else. One cannot enter SS7 easily. Okay. So while designing the SS7, there was no security like authentication. There was nothing like encryption. Only features which were available was say let's take an example, filtering on the point code basis on the STP or at the network element. So possible entry point for the SS7 is VAS service provider. Like we have some VAS service provider like Caller Tunes. We have some VAS service providers like SMTP services providers, or we have some more services. Okay. Then second is the SS7 interconnection. You buy the SS7 access from someone else, some operator, or let's take an example, some vendors are giving out the SS7 access for some few thousands of euros. Then you have the GSM phones. From GSM phones, we don't have much direct access to the SS7. Only the DTAP part is there, direct telephony application part. From there, you can query, you can see the SS7 message, but you cannot query for someone else. You can only query for yourself. Then signaling gateways and the mobile gateways. From there, we can actually also get the access to the SS7. Peer relation between the operators. So let's take an example. If I want to access someone else's SS7 network when my subscriber is roaming in their network, so there is something called the roaming agreement is prepared. In that, there is something called the IR21 document is drafted, and using that you allow other operator to enter into my SS7 network and query do some queries. There is also option for the ISD user part, which is also a part of SS7. There is something called SIP encapsulation. So through SIP also you can actually enter into the SS7, but this the scope is very limited. When we started the SS7 pen testing, the major issue was to convince the operator that issue exists in their network. They are like, if we are only trusted people are there, nobody has the technology, or there are no open source tools. But we still gave them some some tools which are used by the lawful interception agencies. Like this tool can be actually used for the spying on your subscriber, and which is other than the LI. It is going to, an operator's main concern was, is it going to be a destructive testing? So are you going to destroy my network or bring the network down, so then do it? Or is it only going to be the vulnerability assessment? If it is destructive testing, don't touch my network. You can all do everything on the, let's take example, a test bed or whatever test bed they have. How will it affect my subscribers? So in SS7, there are two types of attack. One can go directly to the operators, bring down the network of the operators, or one can actually affect your subscribers. So depending on the attacks, they were like, no, you should only try this type of messages. You shouldn't try this type of message on my network. So all those things were there. Next was the strict warning was given that you shouldn't try any destructive messages, or you shouldn't try any DOS attacks. Next one is what was the method we used for the scanning. First, we speak to the operator, do the basic conversation. After that, when they say that okay, go with the testing, there is something called as a two parameters which try to scan. One is the internal parameter, other is the external parameter. Internal parameter is the one which we connect to the internal network. We connect to the SS7 network of the operator from internally. They give us the access from the internal network, and then we try to do the assessment. But most of the time, the results which came out of the internal assessment are very what you can say vague. You cannot say this could be the false positive, because most of the time the operator allows every SS7 message originated at his network as a legitimate message. Okay, there is something called the external network. So here we connect it from the operator, someone who's roaming operator or roaming partner with this operator. So let's take an example. If we have an operator in Malta, X operator in Malta, so if you want to do the pen test for this Malta operator, we have to connect to his roaming partner, and from there we try to enter into the SS7 network of the Malta operator. Okay, so this is basically how the internal one. Oh, wait a sec. Just a sec. Yeah. So this is the internal connection. Okay. So we connect directly to the STP of the operator. From there we query all the network, or we can go for the external connection and we query from the gateway from the external SS7 network, and then we query for the gateway STP. Okay. So most of the time operator is only concerned about the external test. He says like, okay, in internal pen testing we might get some false positives, so why don't you do only the external pen test? And frankly speaking, the only fruitful test in the SS7 is the external pen test. Okay. Let's go for the next one. So what we did while doing the scanning, our approach was, first we get the global titles from the operator. Global title is something like a WAN IP. If you speak about in the internet terms, it is something like a WAN IP. So we take those global titles from the operators and we try to scan them. Okay. So for that we use some proprietary exploit, or we use something called as an empty TCAP message. Okay. So we try to check whether this global title is dead or alive. If the global title is alive, then we go for further more testing. Like we try to see what all services are hosted by this global title. Let's take example. There is some map services are hosted like HLR, VLR, MSC, USSD, or some more services like SDSN. Okay. So this is just a basic diagram about how we do the scanning method. Next one was how easy to get the external connection. Most of the time, operators are scared to give the SS7 connection unless and until you are ready to pay huge money to them. And they are like, if you want to send some messages, at least with us, it was like, if you want to send some messages to other operator, you should get the permission from the operator for which you are doing the testing, and you should get the permission from us before sending any messages. So it was like from both sides we have to take the permission to send the SS7 messages, and then only the operator will allow us. They are charging us approximately few thousand as a deposit, few $1,000 of the deposit, and then they will be charging us for the per MSU, the per message charges were there. Next thing was connectivity was mostly provided with the M3 UI. It is the IP based MTP user part. Okay, so next one. Internal connection, it was easy to get the internal connection, but most of the time the issue was we have to go directly to the data center. From their STP they will allow us the connectivity, or they will allow us from the corporate network. It was most of the time it was M3 signaling. Okay. Connectivity issues in internal connection, most of the time M3 provisioning was there, but not the map routing. Map protocol routing is necessary to perform the SS7 assessment. Then you have map looping happens because of some improper routing in STP. So what will happen, if you send any message, it will revert back to you. Or if you send any message, there will be some UDTS message or some destination not available message will be there. So it will return back to you. So this is looping issues were there. Next one, operator, most of the time operator thinks that if you are doing the internal test, it means that I'll just give you the IP of the STP or the IP of my signaling router, and you're supposed to do the assessment. Okay. So it was like, it is very difficult to convince them that no, we have to be on the SS7 network to do the SS7 testing. Okay, so operator was like, okay, we'll give you the SS7 testing, then we'll only enable the M3 UA. But the thing was that we need a complete SS7 routing so that we can work as a trusted peer in the SS7 network, so that we can perform the assessment. So scanning from the external perimeter, multiple global titles to scan. So we've automated this using our tool. So we use empty TCAP message to scan the global title. So we send the empty TCAP message back to the specific global title. Then that global title will respond back with different types of message. Okay. First, if the global title is there, the global title is hosting some SSN, valid SSN, then it will reply with the abort message. And if it is either way. So if it will reply back with the abort message, then the SSN is present, subsystem number. Subsystem number is something like a port number on the specific global title. So we have subsystem like HLR, VLR, MSC, then SGSN, GGSN, not the GGSN is not the one. So next one is found the replies responding to the map categories. Filtering level was not that good. So whenever we do the assessment, so most of the time, if a specific operator is there, okay, so what he will do, I have a roaming partner, okay, from his IR21 document, I'll read out his details and I add the range of the global title to be allowed in my network. So he will not do the proper implementation of the IR21 document. We'll look into it further. Scanning internal perimeter, first we found that the local peering was a little difficult. Then DAWA and DUNA. DAWA is a message which gives the destination audit, destination available message is there. Then DUNA message is destination not available message is there. That gives the details of the what all point codes are available to you. Then scanning global title from the internal perimeter gives more result. It means most of the time when we scan the global title from the internal perimeters, as they consider us our global title as a legitimate global title, and say those network and those global, so those operators global titles give us the more results than we expect. So scanning, okay. So we also did the point code scanning. So to get the more visibility on the network, so we try to send some more empty TCAP messages on the point codes rather than sending to the rather than sending to the global title. Okay. So we receive more details about the network. Next one, apart from pen tests, what we found? Apart from pen tests, we found that we asked operators for some information from the STP. We asked some information from their MSCs, and we asked some information from the HLR. So this information typically was like what type of message was tried, originating global title and the destination global title was there. So we tried to figure out why these messages are being sent by the people. We took the say, let's take example, we took one operator and we tried to find out in his IR21 document like which global titles are allowed to send the message and which global title are not allowed to send the message. We did some filtering on that. We found that there are the DOS attempts for the subscriber specific, like shut down specific phone or remove some specific subscription from the subscriber. That's what we found. Next one is information leakage was there, like location of the subscriber, MC disclosure, and the MSC leakage, visiting MSC leakage. Or sometimes we also found that there are some incomplete procedures. Okay, so incomplete procedure, we look into that. So DOS attempts were like cancel the location. It means if you have a specific subscriber, okay, so cancel his location updates. So he will not get any incoming service unless and until he restart his procedure of location update and performs the actual transaction on the network. Then only he will get the service. Purge MS is something that allows you to switch off the cell phone from the network. So whenever some new phone number is trying to reach that subscriber, then he won't be able to reach to that subscriber. Next one is the delete subscriber data. Allows you to remove the specific subscriptions from the for the subscriber. You can either alter the subscription or you can do some more stuff to it. Information leakage were like cryptographic keys, like current and the future keys. So there is something, there's a message in the SS7, something called as a send identification that allows you to send the message, that allows you to give the current encryption keys as well as the future encryption keys. So these keys can be used in the further attacks. Like you can use decrypt the A5/3, which Carsten already presented in CCC, Chaos Communication Club, I guess. So he already presented in that how to use this current encryption keys and perform the interception of the message and the call. Okay. And if you go for the future, how to use the future encryption keys, let's take an example for a specific subscriber. I got the future triplet, authentication triplets. I'll feed this authentication triplets into my custom phone. Okay. Now let's take an example. I'm trying to make a call, and if the BTS trying to authenticate me, I can use this future authentication triplet and make a call on behalf of this user. So this is another advanced version of the identity impersonation which we can do here. Okay. Next one is the MC disclosure. So MC is something which is a unique what do you call it? Unique number which is unique all over the globally unique. So what it does is it allows you to identify a specific cell phone number by some identity. So you can relate from send IMSI messages there. So that will actually give you out the MSISDN, which is a cell phone number to the MC. Next one is the visiting MSC leakage. So what most of the time they try the SRI message, send routing information message. So what this message does is it gives out the roaming number, provide roaming number as well as it will give out the visiting MSC, to which MSC this specific subscriber is connected. Okay. So what you can do for the further attacks here are, let's take an example. You can insert the subscriber data. If the subscriber is prepaid, we can make him as a, make him as a postpaid, and we can make him appear as a postpaid. So what will happen? So before, let's take an example. The customer is trying to call. Okay, we did a insert subscriber data and change his subscription method. Okay, so what will happen here? He will not get billed for his all calls. Okay, so most of the time in prepaid, you try to make a call, the calling entity, the MSC will check whether this subscriber is allowed to make a call or not. If he is allowed to make a call, then only if the balance is there, then only he is allowed to make a call. But if we change the subscription status using insert subscriber data, okay, then we will be able to say that, okay, allow call him by default. You don't have to check to the GSM SCF and directly allow the calls. Okay, the next one is users of the MSC, visiting MSCs, you can purge the subscriber or remove the subscriber from the active subscriber list, causing the denial of service. So this is all we can do with the if we get the visiting MSC of the subscriber. Why incomplete and unauthorized procedures? There are two main messages we found. One was the send routing information for SMS, other was the send routing info. So these two messages are supposed to be providing the IMSI of the subscriber as well as the visiting MSC of the subscriber. So there is something called the home route, SMS home routing is implemented. Most of the operators have not implemented the SMS home routing. At least the three of, we did the scanning for the 8 operators, and out of them, 7 were not implementing the SMS home routing. So what is SMS home routing is, it allows you to keep a track of all the SMS billing. It will allow you to keep a track of what all SMS was sent, how many SMS were sent, and he will be able to bill the SMS accordingly. Okay, but if you don't have the SMS home routing, then what it will do? It will directly expose the IMSI of the subscriber as well as it will directly expose the MSC of the subscriber. So what you can do, you can directly send the message directly to the MSC. So here, there is a vulnerability is, you can use any originating caller ID. So you can change the, say, subscriber, the SMS is coming from XYZ, and you can directly send it to MSC, and MSC accepts that. Okay. Next one is the send routing info from external perimeter. So practically speaking, when you are using the send routing info message, it should be only in the internal perimeter. It shouldn't be exposed in the external perimeter. So whenever call comes here, I'll just explain. So we have here a gateway MSC. Whenever any subscriber from the external network comes to this gateway MSC, gateway STP, you can say. First, it will go to the gateway MSC. From there, it will try to send the send routing info. Then he will provide the roaming number. Then it's the job of the gateway MSC to connect the call. Okay. So this message was never supposed to come from the external perimeter. So if it is coming from the external perimeter, you should either block it. You shouldn't at least respond it. Okay. Next one is the anytime interrogation. Now, most of the time, what operator does is block the anytime interrogation message, so from the any unauthorized entity. But there is something alternative to it, which is called as a provide subscriber info. So what this message does is, it gives all this details similar to the ATI, the anytime interrogation message, but it is coming from the MSC. So you either instead of querying ATI, anytime interrogation to the HLR, you can directly query this message, a PSI message, provide subscriber info message to the MSC, so that you can get all the details. Okay. Next is a send MC message, which actually exposes the MC of the subscriber, also exposing the HLR of the subscriber. So aim of this one is the privacy leakage as well as the location tracking of the subscriber. There is one more message in SS7 called the PSL, provide subscriber location, and send routing info for location, PSL. Okay. So what it does is, it will give you the to which JMLC you can query the location of the subscriber, and when you send this message PSL, provide subscriber location, it will give you the approximate latitude and longitude for the customer, for this specific subscriber. Next one is the major reason. Okay, what was the major reason behind this vulnerability? One is the improper implementation of the IR21 documents. So what operator will do? Okay, now this new roaming partner came to me to perform the roaming agreement. I will see his global title list, and I'll add the global title range in my STP. Okay, now allow any range from, say, 1, 2, 3, 4, 5, 6, 7, 9, 0 to 900 into my STP list, and everywhere in the network element. So once you add this, it will, so any global title which is under this list will be able to query any network element of the operator. So best thing to prevent the SS7 attacks is you can use the fix the IR21 document, fix the network as per the IR21 documents. This actually creates a loophole in the security. So what we suggest as a first step, we implement the IR21 document strictly. Like in IR21 document, you'll see what are the MSCs of the operator, what are the HLR of the operator, what are the USSDs, what are the SMSCs of the operator. All those things you have to check manually and implement it properly. Allow query only if the subscriber is owned by the roaming partner. Now, let's take an example. One subscriber is roaming in India. Okay, so let's take example my cell phone. I have Dubai UAE SIM. So my UAE SIM is roaming in India. Okay. Now, if my operator, which is the SIM which I am using, want to query my location, so he should be able to query only my IMC. He should be able to query only my IMC, not the IMC other than his subscriber. Like if it's Etisalat, okay, so he should be able to query only Etisalat subscriber, not the Indian subscribers of the operator. So this is the one way. Perform the filtering at the STP level for the global title which are not the network element as per the IR21 document. So STP has a filtering policy, so which allows you to filter the global titles. Okay, now these global titles are querying the network. So you should allow or not. This is the facility there in the STP. There is a complaint for the global title which are coming from the roaming partner but are not valid global valid global network element as per the IR21 document. So most of the time what these operators can do, they can file a charge against file the complaint in the GSMA, and the GSMA will take a proper action on it. So what we'll be doing today, we'll be releasing one tool for the SS7 as well as the one simulator SS7 network, so that you guys can practice on it. You can learn about the SS7, how it works and everything. So there is one tool, existing tool is there called the SS7 mapper. I think it's by the Insulator, I don't remember the exact name. So it is based on the Osmocom stack. Okay, does the SMSC HLR VLR MSC HLR test as per the README, uses the Erlang language for the programming. The tool which we'll be releasing is Safe7, based on the Mobicent SS7 stack. Okay, so this stack will be basically based on the M3UA over SCTP. Does all the tests like HLR, VLR, SMSC or SGSN. Easy to use menu-based approach. Okay, you don't need to worry much more about it. So we are also releasing one SS7 simulator. So this simulator will be able to host some network element as per the SS7. You can run your own baby telecom, baby SS7 network in your own computer. Okay, it allows you to simulate SS7 network in real time. Supports only the MAP protocol for now, because till what we have found is the MAP protocol is the only part which is more vulnerable in the SS7. Where to download the tool? You can go to this URL and you can download the tool. And we are also demoing this tool in the Black Hat Arsenal. So we'll go for the demo before the questions. I'm sorry it's taking time because I should have kept it on unpaused. So currently tool is very garbage state actually. So I'm running one server here which is VLR as a VLR. Okay, another server which will be as a STP. Okay, so which will be doing the routing part. Okay, so we'll running the STP, we'll run the VLR. Okay, and we'll run the Safe7 tool. So it is just we are running the mobility applications of the SS7 map messages. So it's all doing the handshake with the SS7. I'm connecting to the SS7. Oh shit, it's not coming there. Okay, come out of it. Is it visible? No? How do you do it? No, my screen is not visible. Can I drag it there? Let me try to see something else. No, I have to do it with the help of the screen. I'll drag it there. How to go for the full screen? Where I see? How do you go to the full screen? Yeah, there it is. Okay, so I have to shift a bit. Oh shit. So let's start again. This was actually, I was giving one training in PwC, so the folder is the same. So we'll be starting the server, okay? So which will be acting as a VLR, okay? Then we are starting one STP here. So let the STP be started. The code is not that clean, and we'll start here one client, okay? It's just the basic things need to be done. It's not any rocket science now. So let's wait for the connection to be active. So one connection is there, okay. Now let's try to send some messages in the SS7. Say we want to send, let's go for the send identification. Which one is that? 7, okay. So 7, so he'll be asking me the MSC. So MSC address is 10,000, is it 10,000? Correct, right? So SSN for the VLR is 7. Now we'll enter the first 2 digits of the team C, second 2, then 3, 4, then 6. Okay, now let's look into the bar chart. So if you could see here, first message is coming from the client, which has a point code 40. Okay, second message is coming going to the STP, which has a point code 10. Then from point code 10, the message is going to the VLR, which has a point code 30. Then the message is send identification. Then this is all the info. Like I want the send current and future encryption keys for this TMC. Okay. Then if you see in the result, you will get the current encryption and the current authentication triplets for this subscriber. Yeah, this is the MC. I'm just using the garbage MC right now. Okay, so this is the MC of that the subscriber. Okay, and this is the encryption authentication triplet for this guy. So what I can do now, I can take these authentication triplets and insert into custom phone, maybe Osmocom or some other phones, like I have done with the Micromax as well. So I can put this triplet in the Osmocom phone. After putting this triplets, now I try to make a call. If network authenticates me, I can use the authentication triplets and try to make a call. And the network will accept the call. As the authentication is successful, the network will accept the call, and you will be able to use someone else's balance on behalf of it. Okay. So let's see some more demo, some other application also. Let's start the HLR part. This is the one. This is the one. So instead of VLR config, we'll run just HLR config. HLR config. Let's see what is there in HLR config. I don't remember the global title. So these are the parameters of the tool at the HLR. So what is the global title here? Local GT is 20,000. Okay. So we'll try to do, yeah, HLR. Okay. We are running a HLR now, and we'll go to this tool again. Okay, this is the STP. This is our tool. Let's see if the handshake is happened. Yeah, the handshake is happened with the HLR. Okay, now we'll try to say send location update message. 1, then MC, let MC be anything. Then HLR address is 10,000, no 20,000. Okay, now if you look into this one, so we try to perform the location update of the subscriber. Okay, now we got the reply as an insert subscriber data. Okay, so what will happen is whenever I perform the location update, so HLR will insert all my subscription details back into the back into the VLR. So those subscription details will be used, whether I am allowed to make or cell phone original call, whether I am allowed to receive the call, whether I am allowed to send SMS. All those details will be there in this insert subscriber data. And once everything goes well, now you receive the update result last update location. It means the location update is successful. Now, any service which is going for any incoming service which is going for this particular subscriber, okay, will be going to this global title now, okay, which we've defined for this client. Okay, what is the global title of the client? We just look into it. So let's go up. So we'll see here the TCAP. We'll see SCCP. Okay, calling party is there. So in calling party, we'll get the global title of the originating party. So 30,000 is a client, whatever client I'm using. Okay. If you are doing the real-time assessment, so you have to fill all the details. I've explained in the GitHub. Very basic documentation is there. So it will explain you what all things you need to enter. So any service, incoming service going to this subscriber, which we updated the location for, okay, will go to this global title now. So if I send the SMS, so SMS will first go to this guy. If I send a call, so the call will, the ISUP message will be initiated with this guy. Okay. So now the vulnerability here is you can actually tap the OTPs here. You can tap the OTP and you will be able to receive the OTP and you will be able to do no matter whatever things you cannot do. So that's it for now. So let me know if you have any questions. It's a point code. In SS7 there is something called as a point code for the MTP level. I'll just show you in the screen. Where is it? Okay. Why it's not working? What's going on the other screen? So let's look at the actual real SS7 messages from some test we did. So I'm querying the anytime interrogation message. If you see this, these are the point code based on the M3UA. Okay. So what it will do, it will route the packets from one end to the other end of the So we are connected to the STP here. So we'll be sending this message to STP. So this the first one will be OPC. Originating point code will be ours. Destination point code will be the point code of the STP. So in SS7 there is something called the point code and the global title which is used for the addressing. The SSN, the point code can be used at the say SCCP level or as well as in the M3UA level. But if you want to use some more intelligent routing, so most of the time the SCCP is used for the intelligent routing. Any questions? Yes. Can you give a mic to him?
Yeah, nice talk.
Yeah, thank you.
So the question is, most of the work that you did, is it from the external entity?
Yeah, most of the time we prefer the external assessment because it gives the actual result and it exposes which operators are vulnerable and everything.
Did you have to pay for it or is it given?
Actually, so what we do is whenever we get SS7 access from any operator, let's take example, we want to do a PT, so we have operators who are helping us in doing this. So we take the SS7 access from them and we check whether the assessment we are doing for the operator. Let's take example, we are doing assessment for XYZ operator in India. Okay, so we try to enter from this our sponsored SS7 to this SS7 network of the India. So we have to take permission from the both sides that we are conducting this test. So you should allow these messages.
So how many global titles are there typically in a network?
It's huge. It's huge. It could be 1,000. It could be more than that. Most of the time, this is also include the subscriber list. So it could be say 10 million subscribers also, because whenever you send a send routing information message, so it is sent on the MSISD or subscriber number. So it could be in millions also.
So were you able to do any research from a GSM messages or anything beyond the networks?
So what do you mean by that?
From a phone, like you said, the other
Yeah,
ways.
from phone there is something called as a DTAP, but from phone you don't have that much reachability to the SS7, and it is still questionable whether we are able to get actual SS7 access or not. But it is only the DTAP part is available from the cell phone.
Thank you.
So more questions? Yes.
Maybe I missed it. Can you please elaborate on, if at all, any encryption, decryption happening and how?
No, in
it is-
SS7 there is nothing like an encryption here, or no authentication. Username password part is not there.
Okay.
So it is everything is a plain text. You can just view whatever message is going on the network.
Okay. Now that you have given us the hope that it can be done, so you must be providing solutions also. For
The solution is, like I said, right, implement the IR21 document properly, or you can also implement the SS7 firewalls. But again, SS7 firewalls has to implement the IR21 document at the end. If they are implementing IR21 document properly, then most of the cases there is no need of firewall also. But only thing is that some network element might not support the filtering level. So that for that purpose you have to use the firewall.
Thank you.
The tool which you have demonstrated here, is it just for our understanding, or we can do some real pen testing with this
Yes,
tool?
you can do some real pen testing. There are some more things to be added in the tool. So I'll be adding it and keep updating on the GitHub. So you can do the real SS7 testing or testing with this tools.
So, I mean, how far we can go with this tool?
You can do all the pen testing, all the map message, most of the map messages which are vulnerable you can do using this tool. So there are 5 to 6 binaries in here. So this is let me check. Where is it? I have to go here. Just a sec. So if you see here, there is the command line. So if you see here, there is a mobility is there, so which allows you to do the mobility management messages. Then you have a server which actually acts as either VLR, MSC or HLR. Then you have SMS which allows you to do the SMS related message, sending fake messages or receiving fake messages. Then you have STP, which is actually a signaling router, basic signaling router, which does only the routing for the 3 to 4 point codes. As I created just a baby telecom, so it is just for the few global titles. Then you have the USSD related services, so you can receive and send the USSD services. So you can actually use this in a real-time scenario. You just have to change this config file. So you just have to change this config file with the actual parameters. Like if you have the server's IP, will have the STP IP will be there. Then STP will allow you some specific IP that will from where you actually connect to the SS7. Then you have server ports and all those things. If you fill this up, you will be able to.
So would this work only when we have got the SS7 access?
Yeah, it will only work if you have the SS7 access. It will not work like that.
Can you tell in a little brief about what we can do in a penetration test when we do not have the SS7 access?
Frankly speaking, if you are doing the SS7 access without SS7 access, it's not possible. You have to have the SS7 access, and it has to be most of the time the external test. We were doing one test in Nigeria. Okay, so we found that the operator is not ready to give us the internal access. He was saying that if you want to hack it, I will just give you the IP and you have to hack it. And it was only the TDM part. He was not even giving the IP part. So we said that we have to convince him that okay, no, first if you want to hack us, if you want us to hack the SS7, we have to be on the SS7 network. It is not just a way you can give us the IP and we can do it.
Okay, thank you.
The SS7 simulator, you can run it locally. You don't have to do anything. So you can run it locally and you can try all your messages. So I'm adding some more difficulty levels also, but it is going to be in future. So those difficulties will be like you can spoof the global title, you can enter something else, or you can also do some like call tapping thing. But it will not be offensive. Will not be promoting. I'm not promoting, but it will be just for the POC case.
As you have mentioned that data which is being sent, it is in the plain text, not encrypted, something like
Can you be loud?
as you have said that data which is being sent is in the plain text and it is not encrypted and such like that. So don't you think that this is something a loophole in that, something which can be attacked as easily or not? If other guys
I'm not getting you what you're talking about.
No, I am saying that data which is being sent, it is in the plain text.
Yes.
So don't you think that it is a small loophole?
It is a loophole, but most of the time you're not able to tap the SS7 messages as it is going on. The most of the time, whenever you do this thing, a peering operation or a roaming agreement with the operator, it goes on the MPLS. And it is actually a loophole that it is not encrypted.
So in future, how it will become overcome? Or there is
Most of the time, there is no new standard came up in a 4G, which is called as a diameter. So it is completely IP based, and it has some security features, but I'm more to study into it.
Thank you.
So I think next 5 to 6 years, the SS7, the 2G, 3G will be gone out of the market because the 5G is coming and 4G is coming. So I think there will be no 4G, there will be no 2G, 3G and the SS7 in the future maybe.
Akib, when you say that you have got SS7 access on a technical side of point of view, what exactly do you mean?
Okay, so we have some SS7 access from the operators. So what these guys do, they give us some IPsec credentials to connect to their network. From there, they provision our IP into their SS7 network, and from there we will be able to make some queries. We will be receive some messages, send some messages, and we have to tell them what messages we will be sending. All those things will there.
Okay, thank you.
Any questions? Yeah, there.
Is this tool based on SS7 mapper and JSS7?
No. It is based on the JSS7.
Okay, the
Yeah, it's a MobiSync one. Yeah. No, we don't need any hardware for this. You can just simulate it anywhere, which has support for the SCTP protocol, but it has to be the Linux machine. What? No, the program I'm giving is the SS7 simulator for the core network, like HLR and SMSC and VLR. But if you want to run the tool you can run it in the real SS7 network as well.
Excuse me.
Yes.
Seeking clarification from about 2 questions ago. While all of this is required access from the operator for you, what are the risks of an adversary passively tapping it and therefore not being caught in any sort of monitoring system?
So you're saying that someone is tapping the SS7 network and not being
What is
caught.
the risk of that? Is that a feasible risk?
Yeah, it is a feasible risk, but most of the time tapping the SS7 network is a little difficult. So in real telco, there are three interfaces. Okay, one is the user data, other is the ONM, and other is the last one is the corporate. So most of the time, whatever data you send over the SS7 or everything, it will go under the user data path.
So the risk of a malicious actor passively monitoring or intercepting messages?
That is less, because in telco everything is separated, segregated everywhere. Okay, so you cannot just go and tap or sniff the thing unless and until you are a lawful interception agency.
Thank you.
Yeah. Some more questions or are we done? Okay, good. Thank you.